Hello, my name is Brandon Clayton, the Algebra Guy. Today we'll be talking about how to simplify algebraic fractions. Algebraic fractions, as you see on your screen, how to simplify these fractions and even algebraic fractions. So without further ado, let's get to it. So as I normally do, let's start out with the questions that we want to answer for today. First question is, what is a simplified fraction? And how does one simplify a fraction? How to use a factor tree to simplify? And when would I need to use it? Those questions and more we will answer in the following lesson. So let's jump into it. So first question, what is a simplified fraction? A simplified fraction. A fraction is considered simplified if there is no common factors in the numerator and denominator. So no common factors. Now, if you need a review on factors, I encourage you to go back to a previous video I've done looking up how to factor and take out common factors, least common factor, greatest common factor, and so forth. So that's going to be really important moving forward. So make sure you get that down. So here's an example. 2/3 is a simplified fraction. Why? Because there are no common factors of 2 and 3. There are no common factors. And to reiterate again, if I were to look at 2, the only factors I have for 2 are 1 times 2. The only factors I have for 3 is 1 times 3. There are no other factors. So because of that, the only other factor they have is 1. There's nothing else you can do to simplify that. However, if I were to give you the example 10/15, this is not simplified. Why? Because 5 can be taken out. If I were to have 10, well, actually I'm going to show you that here in a second. But they both have a factor of 5 because 5 times 2 will give you 10 and 5 times 3 will give you 15. So this can be further factored and we'll demonstrate that here in the following examples. The process of simplifying a fraction is often called reducing a fraction. So just keep that in mind, that sometimes your teacher or a test may say reduce this fraction or simplify this fraction. They really are referring to the same thing. Some even argue that reducing is not the best wording because we're not making it smaller. We're making the numbers smaller, but the value is not smaller. So if you remember, equivalent fractions have the exact same value. So reducing is a word that some teachers really don't like, but you get the idea. They're both the same thing, simplifying and reducing. All right, let's practice this. How do we reduce or simplify a fraction, an algebraic fraction? So here's what we do. First step, rewrite the numerator and the denominator to show the common factors. So, and once you start doing this a lot, you're not going to have to do all these steps. You'll do it pretty quickly. And you can just go from the original question like this straight down to the answer just with a little bit of mental work. But I want to show you each step and what's going on. If needed, factor the numerator and the denominator into prime numbers, which we'll do. And so let's go ahead and do that. So 18 and 24. The first thing is rewrite the numerator and denominator to show common factors. Common factors. What factors does 18 and 24 have in common? Well, I'm going to show you this way, and I want to continue to do this because I want to save time. But let's think about, what are the factors of 18? We got 1 times 18 is 18, 2 times 9 is 18, and 3 times 6 is 18. I don't think there's any more because it's going to start repeating, going backwards. 6 times 3, 2 times 9 times 2, and so on. So that's it for our 18. Let's look at the 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and we're just going to start repeating the same thing backwards. So that's enough for our factors on both sides. Now look at both columns and figure out what's the greatest one they have in common. Obviously they have a 1 in common, right? They have a 2 in common, but really I'm looking for the greatest common factor. That's going to make our work so much faster because if you don't find the greatest one, we're still going to have to continue to simplify or reduce to get to our simplified answer. So these are in common. They have a 3 in common, but the biggest one they have in common is a 6. So that's what I want to take out. So we're going to rewrite this numerator. This equals negative, and we're going to draw a line here. And instead of 18, we're going to say that's the same thing as 3 times 6. And instead of 24, we're going to say that's the same thing as 4 times 6. And step 2 says simplify using the equivalent fractions property by removing the common factor. So if you divide the same thing on top and bottom, it's still equivalent. That's the equivalent fraction property. So if I divide out 6 and divided 6 out, this is still the same thing. Well, 6 divided by 6 gives me 1, so that goes away. Now, all I have left is negative 3 over 4. And there's nothing else I can take out of 3 and 4 because they share no common factors other than 1. So we leave it just like that. And that's it. So what did we just do? So recap. We took the numerator and denominator and we found the greatest common factor they have. We broke it into those common factors. We saw 6. They both have a 6, so we said 3 times 6 and 4 times 6. And we saw that we can just eliminate 6 on top and bottom because 6 divided by 6 is just 1. And we got our reduced fraction, 3 over 4, or negative 3 over 4. All right, what about this one? How can we do this one? Now, I'm going to try to just think through this one, right, without doing a whole factoring like I did a second ago, because that's going to take a while. I want to show you that we can do this a little bit faster than that. So if I think about it, let's start with the smaller number. I know they both can divide by 2, so we can kind of mentally check that off. We got a 2 that's in common. What about a 3? No, they can't. 32 divided by 3 won't work. What about 4? Yes, 4 will work for 32. Will it work for 56? I believe so. Actually, I know it will. So 4 will work. So I'm going to cross out 2 because I more likely will use 4, the biggest number. How did I know 4 will work? Because if you divide 4, you get this 14. So I know it goes in there evenly. So I know 4 will work for both of those. Will 5 work? Well, the rule for 5 is for it to be a multiple of 5, you have to have a 5 or a 0 on the end, which doesn't work for this. What about 6? 32 divided by 6 is not a whole number. That is not going to work. 32 divided by 7. What about 8? 8 may actually work because 4 times 8 is 32 and 7 times 8 is 56. They both have an 8 in common, so an 8 is the bigger number I'm going to use. So now I'm going to break this into 8 times 7, because I know that's 56, and 8 times 4. So I just did my second step I did my first step where I rewrote this into the factors where they share a common factor that is 8 in this case. So that's going to equal negative, well, this is going to cross out, right? Because they're the same thing. Cross that out. I'll get a new color. And that leaves us with negative 7 over 4. Those are two numbers that do not share any common factors, so this is all we can do right there. So that's the simplified version of this. Oh my goodness. What about this beast here? So this time I still want to get this factored, but I'm going to use a different method. You can still do the same thing, but factor trees become useful here. What a factor tree is I'm going to take my numerator, 210, and my denominator, 385, and I'm going to create factor trees in order to try to figure out what's all the numbers it breaks down into to get to my answer. So what two numbers can I multiply to get 210? It doesn't matter which ones you choose. I know it's a 2 in here because there's a 0. 0, 2, 4, 6, 8 will give me a division of 2. But I also know there's a 10, so I'm going to use 10. That's a little bit bigger, and to break these numbers down better than having a really big number of 105 and 2. But I can keep going, right? Because 10 can break down into what? 5 and 2. I can also break 21 down further because that goes into 7 and 3. So you see what I did? And what this is telling me is that 5 times 2 times 7 times 3 would give me still the same answer of 210. I'm going to circle those because on this factor tree, sometimes these are referred to as buds because you got this little bud on the end. That's as far as we can go. And these are the numbers that you can use to represent the 210. So I'm going to rewrite those numbers up here on top. 5 times 2 times 7 times 3. Because that was actually our next step. Rewrite the numerator and denominator as the product of primes. So all these numbers are prime numbers because they only have factors of themselves and 1. 5 times 1, 2 times 1, 7 times 1, and so forth. Let's see what we can do with our 385. The first breakdown is the hardest because this is such a big number, but I believe it divides, I know it divides into 5. So let's see what that number is though. So let me do that math real quick. 385 divided by 5 goes in there 7 times, and 35, and that looks like 77. So I know it breaks down to 77 times 5. Now 5 I can do nothing else with, so I'm going to circle that because that's one of my buds, like the bud on the tree starting to bloom. And mathematically that's my prime number. But I can break 7 down further, so we're not finished with this one because I can still multiply 7 times 11 to get 77. And now those are prime number buds, if you will, and I can rewrite 5 times 11 times 7. So when you multiply 5 times 11 times 7, you get 385. Same thing, 5 times 2 times 7 times 3. All right, so now why did we do that? Why? Because we want to remove the common factors. Well, just like we did a second ago with the other problem, we can do that here. So we see that 5 and 5 are common, and we see that 7 and 7 are common. And now we multiply what's remaining. 2 times 3, it gives us 6, and we just have 11 on the bottom. So this gives us a negative, don't want to forget that negative, 6 over 11. So all of this right here, if you're going to reduce it down, this is actually the same value as negative 6 over 11. Now, why would you want to do that? What's the point of factoring and breaking it all the way down here and such? Well, it's a lot more appealing and a lot easier on your eyes and on calculations when you're going to have to add these numbers. Which would you rather have? Add 210 over 385 to another fraction or 6 over 11? So that's a much smaller fraction to deal with. It's the same value, but you're giving yourself the opportunity to decrease your decrease the chance that you're going to make a mistake and just save you a little bit more headache unnecessarily when you can just reduce it first. So that's going to be a really important skill to have. What about this guy here? We talked about simplifying algebraic expressions. How do I simplify this thing here? All right, so we have 5xy, or negative 5xy over 15x. How do I deal with this? We're going to do it the same way. Rewrite the numerator and denominator showing the factors. So what are the factors? Well, it's clear that it's just 5 times x times y. Those are my factors. And what about down here? Can I does 5 and 15 have any common factors? It sure does. 5 times 3. So 5 times 3 is a common factor. And, well, 5 and 5 is a common factor, and then I have my x. So we just did in step 1, rewrite the numerator and denominator showing common factors. 5 and 5, they have in common. Now we can take that out, and we end up with, this is going to equal, not just this one. So 5's go away. What else can we cancel out? Good. We can get rid of those x's. X over x. Even though we don't know what that number is, we know it's the same thing. And any number divided by itself is going to give us 1. So that in essence cancels out because that's not going to change the answer at all. So this ends up being negative, a y on top, and a 3 on bottom. And that's it. Negative y over 3. Now, this so this is our answer. I just want to close that topic off. Now, I do want to mention one thing real briefly because I don't want to do a whole lesson on this. Students will get confused. A lot of my students will get confused when they see this, and then they'll see this, and then they'll see this, and ask the question, which is which? Are they different? Are they the same? And I want to go ahead and answer that question now because pretty much every one of our problems had a negative here. And you may see me writing it with a negative on the top or the bottom and such. And the reason you see that is because this and this are the same thing. And this is the same thing. So it doesn't matter where you put the negative, but you got to be careful not to put it up top and on the bottom, because negative divided by negative now changes it to a positive. So this is be a completely different answer. So that's not correct. But just remember that you can put that negative anywhere. You can put it right here in the front of the whole fraction, on the top or the bottom, and they represent the same thing. And if you want to test that out, you could just try it in your calculator. You do -2 divided by negative 10 divided by 2. You can do 10 divided by -2. And you could also put negative 10 divided by 2. You can write it like that. Parentheses or none. So just want to make that clear since you kept seeing that. Did we accomplish our goal today? What is a simplified fraction? We talked about when you don't have any common factors between the numerator and the denominator, it is now simplified. How does one simplify a fraction? Well, we take out those common factors. We can cancel those out, and what we're left with is a simplified fraction. So how to use the factor tree to simplify? We talked about that big number 210 and how we start breaking it down to its prime numbers. Then we replace this 210 in the numerator with the prime numbers and replace the denominator with its prime numbers, and started canceling out what we could, and what we were left with was our simplified fraction. Hey guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.